on Saturday from rating my professor for me at Mainz, give me a 1 rating. Someone couldn't wait to criticize me. That's okay. I was looking at am I a bad professor? I haven't get anything lower than 5 at Fordham College, but anyway, I was trying to get that post available for you guys on Saturday, and I was like, should I still do that? Since I'm unorganized, I'm a bad professor, should I still do that? I still did it since I know that's the right thing to do. And I know people want to learn. So I spent like 6 hours on Saturday from like 10 a.m. to 5 p.m. Non-break in the middle. Just get this done. Take a look. Saying my lectures are only like 1, 2, 3 papers I write on it, use a Sharpie. What is this? Is it just 1, 2, 3 papers? Is it just 1, 2, 3 papers? Okay, so let's see. For the cruise project, we'll have 2 people, 2 or less. It could be 1, could be 2, doesn't matter. And it will be very similar to working in the industry. 2 people, like one working on the software side, another one working on hardware. Makes perfect sense. If you hate PCB design, you don't want to work on any hardware stuff, you just want to do coding, which is fine. So just take the coding role. If you just want to work on hardware, because I know someone really likes doing coding, someone really likes hands-on wiring stuff and doing PCB. So we'll split the tasks, okay? But keep in mind, there's one date, super important date, October the 18th, okay? I'm gonna ask you again at the end of the lecture today. October the 18th, very important date. What are they? If you choose, find a partner, could be a light partner to work on that team. The PCB design, by following this instruction, has to be done. You have to submit it. Whoever is gonna work on that, just 1 submission per team. Okay? Look at it. See how long it is, all right? And if I just worked on, eventually I was looking at the board. It's a little bit complicated, but let me see how long it's gonna take. But after I placed this microcontroller onto the board, and I found out, based on my experience, probably won't take longer than 2 hours to finish the PCB design. But doing everything and posting everything to the website took like 6 to 7 hours. But I will let you know that if you follow this, I hope won't take you like more than 6 to 7 hours for the one who is in charge of the PCB design on the team. Okay? Let me see. Several requirements. I'm gonna open up the rubric for you guys. So here's the project description and rubrics. Okay, so the scope. We're not trying to make something complicated. It has to be simple because we don't have like 5 months to work on it. It's only a little bit less than a month, I think, or a little bit more than a month. It could be some combinations of 2 modules on the board. For example, use a remote. Can you use a remote to switch channels to play different music, right? Seems like that. Or using a remote to control it, the error remote we're working on now to change the, this is too simple, but change the light, like playing like a light night for kids, right? Or we are going to learn how to do ADCs and microphones. Let me see. Lab 8 and Lab 9. Okay, so you'll learn how to do microphones and ADCs. So after that, you still get a chance to revise your proposals. Since we have to, so you have to submit a proposal by this day. But however, you can still change it, make minor adjustments to the proposal. That's not a problem. But now, since you don't know how to play with ADCs, so that could be a challenge for now. But later on, after we finish these 2 labs, you probably want to add more features to your design. But doesn't matter for your first submission. What's the date? October 18th. Okay? What are the submissions? Let's take a look at it. Task 1. Okay? PIC, the PIC board PCB rebuild. That's the one person in charge of PCB on the team, all right? Another one is the project proposal. Just don't think like the project proposal is just very simple writing. No, it's not just a draft. So if you are in charge of the software design, you have to have an idea and draw the software flowchart. If you can have the software done and complete and put in the proposal, that would be perfect. But if not, it's okay. It just at least you have to get the main structure of the software to be put in the proposal. Okay, could be a flowchart, could be a pseudocode, English, right? Could be anything that I can understand because I want to review that proposal over the weekend. Probably after Friday, I see all the submissions. I'm going to review and put comments in Canvas. So to let you know if it's a feasible plan or not. Sometimes you want to plan for very big, right? Especially for beginners. I want to control a rocket. Just kidding. So just make sure everything is going to work. Eventually you'll get a credit and pass. So the first two tasks, okay, for 2 team members on the team, they are due on the 18th of this month. Okay, make sure the 2 of you work on the project at the same time. The proposal doesn't have to be long. I think I has it limited 2 pages. Right, so I have the rubric for each task. I drafted. So let's see. Task 1 is the one I just told you guys. Due October the 18th. One more time. Okay. If you have any questions, feel free to email me anytime. I'll explain that. And task 2. Task 1 is the PCB. Task 2 is the proposal. Take a look at it. And that's 15%, let me see. 30% for the 2 of them combined. And task 3 is a C code and Gerber files. So let's take a look at the timing here. All right, so this week is Lab 7, no problem. Okay. And next week we have the full break, but Thursday no break. But I'm giving you the whole week next week to work on the project, part of the project, including the task 1 and 2. Because it's due next Friday, right? So it makes sense for you guys to work on the software a little bit, work on the PCB task a little bit on Thursday to take advantage of the Thursday, like 3 hours in the lab. No new labs, no Dr. Carlson labs, just the PCB design for the person who are working on the hardware. For the person who are working on the software, you have to start working on the proposal, the flowchart, or even a little bit coding. I don't care, whatever you want to finish on that day. But that day is given to you. I'm not adding a new lab. Make sure you work on it and come to the lab and work on it. Since I will be there, hopefully, I'll see if I will stay there for the whole day. So I can give you feedback about proposal. And the proposal is due Friday. Keep that in mind. So I'll probably stay there for the whole day and collect your input and feedback. What's that?
Do you know if the lab computers in our lab room have the PCB design?
Yeah, they do have. Yeah.
Awesome.
Yeah. Next week, we'll have to continue working on Lab 8, right? Lab 8, microphone. So that ADC is a very important part of the microcontroller. And then Lab 9, following that week. So during these 2 weeks, we are not giving you a designated time to work on the project. So you have to find time. Keep that in mind. That's going to be a hectic 2 weeks. Since week 8 and week 9, I'll try to put more materials to the template, let you cheat a little bit. All right, so make it easier. So have the time to work on the real PCB, your project's PCB design, to include whatever you have to include on the board. Could be the speakers, the ADC, the LED, IR modules, whatever. Okay, so I have to get the hardware done and the code done as well during these 2 weeks. I think that's due the week after, not exactly that week, but the week after. All right, we cannot delay that for even more because it takes, I think, 10 days at least to be shipped from China to here. So we have to submit everything. Let me see. So these are all the same files. I just put the same link here. If you open them up, you can see it's the same thing. Right, just make it more convenient. You don't have to scroll up to find it. So this one, task 4, right? Oh no, task 3 is the C code and Gerber files. That's still the 7th. That's good because we still have time. So 7th, the latest we can do. We cannot do later, okay? The 7th, 10 days after, will be the 17th, for example. It's somewhere around here. Hopefully we can get it here. I'm giving you 3 lectures time. I will be in the lab area, help you soldering, testing your board. So we're not having new lectures during the 3 days. Since I believe we'll probably, very likely will receive the board on this day, right? So give you the board so you can start programming and testing it. And we don't want to just do lectures and give you no time to work on it because you can see the Thursday after we receive the board, right? It's 1 week after we receive the board. I only have 1 week, about 1 week to solder and test the board. Keep that in mind, the timeline, okay?
Are we able to submit a PCB earlier?
Yes, but the shipping, $20 more. So the PCB fabrication is only $5 for 5 pieces, but the shipping is $20 to $25 for shipping. And if we order like 50 boards at the same time, probably the shipping is like $200. But if you just order once, $20 for shipping. I can do it. It's not a big deal. Right? We have money. I think department has the money. So yes, if you want to submit your PCB earlier, that's actually recommended. We can do it earlier, and so you can debug. If you see issues, so you have the chance to revise it. Right? That's good. Not a big deal. Okay, $20 is okay. All right, so keep that in mind. In mid-November, that's the time to get the board soldered and test it. If you see issues, we should immediately submit it, resubmit it, and get a new board. So hopefully I can receive it here and solder and test it here. I can extend it and give you the credit. So for the week, I think, let me see, which week? The week after the full break is over here, right? Because the one working on the PCB design will probably stay in the lab and work on it. So I will try to find the PCB class TAs to come and help, right? Anything else? Any questions on the project? It's my first time managing 100 students. What's that?
Should the PCB be 2-layer?
Yes,
Be
2-layer, yeah. Yeah, we couldn't afford 4 layers or more. 2 layers is cheapest. Anything else? That's it, right? You can always ask questions by emailing me, okay, if you have more questions. Now let's look at one thing. I found one little issue with the in-lab. Wait. Oh, yes, here. Let's start from here. Since I'm trying to provide you with the AM, so I didn't include the details of the AM, the message piece of code into the template, but I think I should. So if I just run the demo because it's difficult to imagine what's really going on here. You know, when you are typing into the message, if you press M, then you start typing. I want to let you think about one issue here. Why it's not getting to the switch and cases? Why allows you to type multiple letters instead of just one, then like a reset or unknown letters?
You're throwing it into a buffer, into like that array.
But why allows you to do that? Yes, that's right actually, but how that works?
The whole I++ thing, IO transmit buffer.
Yes.
Every time it goes through in this while loop, the command is going to be 1 letter and it's going to go in there.
Yeah.
And then the next time in the while loop, you're in the next element of that array.
Yeah.
It's gonna go.
But why it stays in the while loop? Look at the condition. Why?
Whenever you're reading from you start, you're staying inside
It's as long as it's not a return.
As long as you don't press like enter.
Why? Because of this condition, right?
Right.
But why is waiting for this? Because you are not pricing return. So it should do what?
Just wait for user input or whatever.
Yes, right? So when you press in return, what's going to happen?
Then you get out of the while loop.
Yeah, but why it stays? So if it stays here, why it's not keep assigning, refreshing the buffer? And overflows and get out. Because it satisfies it, right? So it's not a return, even though it's nothing. It could be nothing, could be something else. Why it's not keep staying inside? Because you can finish all the buffer assignment really quickly, right? It's only 32. 32 minus 1 is only like 31 times of running or execution. It can finish like in several microseconds. And then quit. And then you press another letter, it can show unknown letter. Let's see, let me show you because someone probably still not getting there yet. Let me open Putty. All right, it's hard to see. I don't know how to do it, but you can tell. I'm gonna tell you what's gonna happen. Okay, it's recorded. You can always review it later. Is there a way to change the font size over here? Right click, settings.
I think there's like a command. Change
Control
settings.
plus, try that.
Control plus.
Yeah.
All right. Nope.
Size.
Size. Nope.
Yeah.
Maybe change settings.
Window appearance. And then font size, there we go.
New template. Change this to like 20.
Yeah, there we go.
Apply. Better. Thanks. All right. If I do it's waiting.
The user read is blocking, right?
Yes. Yes, exactly. So what's happening is if there's nothing being read by it, it's waiting. So in the template, I didn't provide the whole thing here, but now I'm showing you this one because I know if you don't get a code somewhere else, it's difficult. So this one, you are reading it from here as a condition. So it's actually checking here first. If there's nothing getting received, it's going to stop here.
Gotcha.
Just stop at the top. Just stop here over here. It's not doing anything over here. Not doing anything within the while loop. It stop at this line. It's waiting. Whenever something's getting received, it directly assigns to command and getting into it. All right. One more thing I want to let you know. Look at this one. This line. While you start data ready, what does that mean? Are you familiar with that?
The data ready means that the buffer register has data that can be read.
Yes,
That's
and the
what
flag
we
is
want
1,
to do.
right?
Yeah.
Yeah, when I read it, the flag got cleared. However, is this the case over here? What's happening? You press M, what's really happening? So this line was provided in the template because that's the solution I got from other people, okay, from the professor. So now if you look at it, does that make sense? The while you start data ready, does that make sense? Do we need it?
Yeah,
Is it stuck in there?
because you haven't read
Oh,
any
so you
data.
press M, what's happening?
You
Let's
get
look
into
at
the
it.
cage.
Let's look here. So you press M, it enters here, right?
Yeah. Oh, and then you read it.
You
so
read it
it's
already,
resetting
so what's the flag?
0.
Yeah. So what's happening here?
You're resetting it already, so you're getting stuck there.
Wait, resetting where?
Since you're reading it, it's going to 0 afterwards, so you're getting stuck at that while loop, right?
No,
This while loop? So
Zero.
zero.
Oh.
Wait.
So data ready would still be 0 at that point. So you're just skipping the while loop. You're not
Yes,
doing anything.
you're skipping, not
Yeah.
staying.
Yeah. No.
So do you still need it?
No.
So what's the intention of this line? You think?
just in case any more data comes in, make sure you're not, yeah, I don't know.
Like if this
Yes.
person's
There's nothing in the
pounding
book.
on the keyboard.
Yeah.
you
So
don't
so
want
yeah.
multiple inputs.
It's skipping, right? It's not doing anything.
Yeah.
So when you press M, enters it, and skip this one and start here, right?
Yeah.
Waiting for any typing, right? So type something, it's gonna keep being read, and then every time you type, it gets into this loop. So the conclusion is this is not being used. I was trying, hey, do I really need to hold there by doing if it make any sense to my limited knowledge, I'm gonna do this, right?
They did the same thing.
No, because then
And then it gets stuck there.
Yeah.
It's stuck there. Then when you type again, it's gonna get out.
Yeah.
So
and
get
then-
into the next while loop, right?
And then you read it. And
Yeah,
it
yeah.
says
Since
apply.
since it's always just not really doing anything, your user read is always holding it to let you type. So this is not being used. All right. So when you are programming and you see the same issues, how do you deal with it? Just comment it down and try, and uncomment and try again.
Yeah.
That's what I did. I found out it's not being used. It's not changing the result at all. So I just commented out. Okay. So if you go to the in-lab code and scroll up, you see it shows up here as well. Right? Do we need it here? So this is another functionality we haven't used too much. So what is this doing? So press B, right? You press B. It gets into this case, all right? And what's next?
It's being held
Being held by what?
by user.
User read, right? This is also not doing anything. Comment it out. Confusing people, not doing anything. I tried it, it works. So comment it out, same thing, not changing anything. So no worries. Okay? And so another question for you guys. So when you type, after M, you start typing, right? Like what I did over here. Start typing. Oh, let me reset it first. Reset it first. Okay. So if I type, for example, I type some unknown letters J. It shows this because I have a code showing you this, right? It's at the bottom, right? It's unknown code. It's gonna do this, right? Anyway, so if I it's printing out. Okay, if I type M, now I'm typing this. Why do you think it's displaying this string for me? How that works? Is that because I'm just typing, so it's all within the laptop? So I type from the keyboard information goes to the CPU sends to the monitor? Let's see, all right? Okay, so I'm trying to type Shift Z. What Shift Z does?
Reset.
Yeah. Did you see Shift Z somewhere?
No.
So in that case, if I do this, did you see M? I pressed M. Did you see M?
No.
So the PuTTY is not actually displaying whatever you typed in there. So there's no mechanism within the laptop through the keyboard to the monitor. So why, when I'm doing this, it shows whatever I just typed?
Did you code it that way?
You did hit enter.
I haven't. I just typed.
The punch
Oh,
function.
right, yeah.
The punch function.
Potch function. Which one? Let's just look at it and think about this for one more time. What's really happening? You want to see what you just typed in there, right? You want to visualize it so we have a feedback.
It says printf command at the bottom there in the while loop.
Yes?
So that's why you're getting like the letters.
Yeah.
Oh, it's just
You are just printing out over here. So you press one letter, you press one character, it's holding there, right? It receives it, okay, and gets into the while loop, print it, save it in the transmitter buffer, and print it. Print it to where? To a monitor.
Yeah. So if you didn't have that line, it wouldn't print it to your monitor at all.
No.
Okay.
Let's try it.
Yeah. I'd love to see that.
Right, comment it out.
Yeah.
This doesn't have all your code written on it though, does it?
Is that?
This has some spaces where we're supposed to fill in code, right?
No, this is already everything. I already showed you everything. It's different from the template. I just changed something to it. Right. Just do it. Start.
Seem familiar? Cooper was trying his lab, and the putty would never open.
Oh, was it like the issue that the TA told us where like
Yeah,
it
you
crashed
said
once
plug
and
in.
it it set the lock to it and you just had to plug it and plug it in.
Where's the settings? Oh, change settings. I have to do this again.
Putty is. Bro, we program in Cordis all day and putty's the bane of your existence.
All right.
We sit there and wait for like 30 minutes for
Okay.
everybody to work.
Yeah, I typed hello. Doesn't show anything.
Interesting.
And can we receive it?
For sure.
C0
C0 to B7.
Can we still receive it by IR?
Yeah.
Close your eyes, Dave.
Bro, I swear.
Let's
it messed
try.
up, dude.
I'm gonna do enter.
Yeah.
I typed it, so I didn't lie. And
Now we're transmit and then
transmit is gonna be S, right? R.
Transmit it, receive it.
Done.
cool. So you have a buffer on both ends, right?
Yes. Let's talk about it. Just got crystal clear on everything. Okay. No dark corners. So after press M and you typed everything into the window, okay, everything already saved in the transmitter buffer. Okay, we already know that by the demonstration just now. Okay.
Yeah.
Then what's next? I cannot scroll down anymore. Show the template. Can't show all the solutions. Let's see what's going on here. It's a template. Start. So we pressed M, get everything saved in there, done, and press S. So what S should do? It's already saved in the memory, so you got an array, right? It's very easy to do a for loop, while loop, whatever. You can use the index to take out one by one and send it. So the transmission data, the transmission code is already provided. This is very simple, right? What is here? I'll let other people answer that. So the transmission, remember transmission, what's the first step? First step for transmission. Pull it down, right? Pull it down. Then data, right? Then pull it up. That's UR protocol, okay? So that's why the first, this is the block of code. We talked about this on Friday, I think. So it's very simple code. It's a piece of code. It's being used for millions of times. Same thing, being used again over and over again, okay? So first step, you load the duty value into it. So whatever in here will be the duty value, right? The duty value, the counts. Okay, put the counts in there. It's going to start the PWM. Because the PWM pulses will result in a zero logic for the decoder. Okay, so by doing this, you send a zero to the decoder, send a pulse to the decoder. Decoder will output a zero, and you immediately set a timer to define how long you want a 0 to be. That's 1 bit. So that's the baud rate of that UART, okay, for the first bit, the starting bit. So that's how you set up the timer. Right? That's how you set up the timer. Then you move to the next. You start taking out every single bit from the transmission IR transmit buffer. Right? Which is a ladder, is a variable being used for here. Is actually you just pass that argument to this function, which is the IR transmitter buffer. Just pass it to here. How we did that, I didn't show it over here, but you know how to do it, right? Call that function and place that IR buffer into that location of the argument. So when it calls it, it's going to pass that specific ladder from the array into here. Okay. So you get a ladder here. It's a 8-bit. So you need a mask. The mask is a binary number, has 8 bits with the 1 from the LSB at the very beginning, and you start doing an AND logic every time to extract every single bit from the data. So after an AND logic, you shape the mask to try to take out bit 1 and bit 2 until bit 7, right? So take 1 by 1. That's how that works. This one is also a module. It's not being changed at all. So it's being used over and over again. So there shouldn't be any question for this function at all. Looks difficult, but actually it's not. Very simple. It's being repeated for millions of times already. So bit 0, data, 8 bits, and bit 1 is a stop bit. So here should be the duty value, right? Which is what? Whatever duty value it is. And here should be what? 1. Okay? So 1, PWM 1, yes. Oh, no, 0, sorry. Off, right? Off. So PWM off 0 will give you logic 1 at the output of the decoder, right? Okay, cool. All right, so this is a template, so it's okay to scroll down here a little bit. And so what is this S doing? Just think about it. So M, you press it, type it, save into the transmission buffer, right? And you press S, what does S do?
Just goes through the transmit.
Goes and do what? PWM send it, right? So PWM is ready output to what? To the BJT, to the transistor and the LED. So light is out. After you press S, it's not under control anymore. It's out. And whenever that is already in the air, and your decoder will receive it and have a response. What are the response from the decoder? It's going to be digital logic, serial logic. Will be fed into what? UR2. So after press S, all the things are not under control anymore. It's going to be fed into UR2. So must make it ready, right? So how do we make it ready though? How do we make it ready? I mean, when does it know it's ready? It's in the air, right? How does it know it's ready?
When it sees a pull down.
It sees it pulls down. It's a UR module. It's a digital module being written by the Verilog engineers, which will waiting there to detect that pull down, right? That logic 0. Whenever logic 0 is getting received, the UR2 RX will directly take the data in, right? Okay, that's what the ISR does. So you do need an ISR, but do you need a state machine? I don't know. Think about it. So when the data comes in, you just read it, right? Read it byte by byte. It's all controlled digitally by the UR module inside. It's ready read. It's ready designed. It's working as a functioning UR block. So it's gonna give you byte by byte. So if you do a read, I mean, this is just it's not a pseudocode, but this is just what I wrote. I was looking at the solution. I was do we really need a state machine for this? So if you can read from the buffer, okay, received buffer, not the transmission buffer or something else, okay? So the buffer, what I'm talking about, is the FIFO, okay? So if you call this guy, this register, it's gonna read from the FIFO. That's how I read it, right? If I call this register, because the data is already received in that register, I can directly read it. I can directly use it and assign it to my receiving buffer. If I'm receiving a null, I know it's already the end of the string. But the thing is, the way everything was organized is in your M. Let me show this one. Function, I mean the case. What you actually do, I'll let you guys tell me. How is the data being organized in the buffer, in the transmit buffer? You type it, right? You type it. You press enter. So what is the enter? It's carriage. It's a return. It's /R. So you're actually sending a string plus the R. /R. Do you need the R? You don't need it.
Are you sending the /R?
Yeah. You press enter. It's sending. Right.
But wouldn't if you
Let's see.
because when you hit enter, doesn't it get you out of the while loop? That's the case that gets you out of it. So
Oh, that's right. So it's not actually storing that R in there.
yeah, 'cause
That's right.
taking
Yeah,
out
that's
the
right.
while loop.
Okay, that's correct.
And then you just
Thanks.
tack on the null terminator.
Yeah. So this one stores everything, but this is adding a 1 to it afterwards, right?
Yeah.
So you get the whole byte into the whole string into this thing, and so the pointer will point to the index will point to the next one, which is empty, right? And then you get out from the while loop, and you directly assign the new I, which is pointing to the empty location, a null to it. So the while loop does the whole does everything, all the bytes of the string. And then, because every time it executes, it added to itself by 1, so that's why it's pointing to the next in array. So once it gets out from the while loop, the I will be a new I, right? Pointing to the empty location and assign null to it. So you have a string, a null, and what? Oh, no, not string, sorry. Strings, right? Oh, yes, string, actually, the bytes, right? And a null, and a checksum. The checksum is the addition of all the characters ASCII code. So why do we want to do that?
Yeah, check for errors.
Check for errors, if something is getting missed. So since you know everything here is still happening wirelessly, it's not wirelessly, it's still being communicated through a wire, so it's more reliable. So know that you want to get a checksum immediately after you store everything to the array, right? So you have a addition of everything, a summation of everything, and then you transmit it at the receiver side. You can do the checksum again and see if they match. So you'll know if there's anything going wrong or any interference in the air, changing your code. That's the goal of it. That's the purpose of doing that, okay? And then let's come back to the template. I mean, it's important to understand what's going on so you can, because Lab 7 is very similar to Lab 6. So you probably will find out you may not even need a state machine at all. I haven't tested yet, but I was looking at the state machine. There's really nothing in the middle. Very simple, just one line of code. So I was thinking the logic is just basically you are checking. So every time it enters the interrupt, right? You read whatever already being received by UR2. You keep reading. If it already reaches a null, so you have bytes and null and checksum, right? Already reaches null because you know this one will add an index later, so it's going to point to checksum afterwards. If it's reaching there, you do a read one more time, so that read will be what?
It'll just take the null character, right?
Not the checksum?
No, it would take the checksum because you're doing plus plus inside of the
Plus after, right? It's incrementing after. So after reading a null, it reaches a null, it's going to increment the index. So it's pointing to checksum now. So you do a reading again, it's going to read the checksum and put it to the end. So that these two lines will deal with whatever the last 2 bytes, right? So what about this? So else. So it's not reaching there yet. So for else, for whatever above, do what? Just read it.
just receive it.
Read it and increment it. Okay? And what else do you want to do? Wait. Okay, so after this, you have to make sure it's done, right?
Yeah, you gotta make sure that like once it's pulled.
Oh, it's actually, we can do this. So what I'm trying to say is we need a flag.
Yeah.
Because every time you did something, you need some credits. Alright? In the flag. Okay?
Couldn't you read from RC reg? So on the top if statement, when you read from RC reg twice, isn't it possible that there's only one character in the FIFO?
It's being read in order. I don't even though there are two, but it's just being buffered, but it's not. But you don't have to read twice. It's after this is read. You read it next time. It's gonna read the next one.
Yeah, but what if there's only one character in the FIFO?
One character in the FIFO.
Yeah, because won't it only fill the second part of the FIFO if you don't read it before the second byte arrives?
Mm-hmm. I mean, do we need to make any changes to this? Is that what you're saying? I mean, since the datasheet didn't show us the structure of it, but it seems like a FIFO is something else, and the read register is over here, is reading it. When it's getting read, there's a logic circuits to clear the FIFO location, but I don't know how that works actually.
But I just mean like, so if you send like a character and it receives the character, it'll fill the first
Yes.
part of the FIFO.
Yeah, the second one comes in, it's gonna fill the second one. So
Yeah.
it's giving the opportunity for the first one still staying there to be read, right?
Yeah, but what if you read that first character out before the second one fills the FIFO? And then you
It's
try
always
to-
coming. It's always because the data is coming. You press it in the air. It's already received. So I think the digital circuits will keep shifting and store two in there at the same time. I think two will be saved there at the same time. It's difficult to guess, right? Since we cannot see the digital circuits. But we don't have to worry about that yet, because we just need to know if we read it, the things being received will be read. That's it. That's everything we need to know. That's the good part of being an embedded system engineer instead of like fundamental, the bottom level Verilog, right? Have to deal with every single detail like flag, interrupts, and everything.
For the receiving message equals true, wouldn't you want that like in your else statement, or do you need it in your if statement?
Because after the checksum is done, it's read, I think it's ready to turn on the flag. Right?
Got to the checksum, so you're done reading.
Yeah. Yeah, and then
Because you got to the checksum, but how about like, isn't that if statement also going before you get to the checksum as well? So if you're like reading in the like.
yeah, so it's going to else, right? For the
Yeah.
rest.
So wouldn't you still want to receive the new message while you're in that else? Because if you're in the middle of it, right, and you're checking the next one and it's not your null character, you're going into your else, wouldn't you still want to read that new,
While you are in
wouldn't
the-
you want to read that value there?
I didn't get that. Can I say it again? Sorry.
So like you're only going into your if the next character is your null, right? All the other time you're just parsing through the through the register like normally, right?
But this one will be read, right? So every time it's getting into
Oh,
here.
I see. Yeah, you're still equaling it to the
Yeah.
next part of the buffer.
Yeah,
I
it's
see,
reading.
Gotcha.
Yeah, yeah, yeah.
So then receive. I
Yeah.
see. Okay.
Yeah, so I haven't tried this yet. I just wrote it randomly 5 minutes before the class. I was thinking probably something can be replaced. So try it if you are curious about that. Since I didn't provide you with the, it's almost everything here already. Oh, one more thing. So this flag is unused. I don't know why it's over there, like receiving busy. So it's in the template, it's in the solution, but it's not being used. I commented out, it's not changing anything.
Is it Lab 7? Is it
Lab
built
6.
on it?
Oh, you mean Lab 7? Lab
Yeah.
7,
She's busy.
yeah, I'll take a look at it. Oh, maybe used for Lab 7. I don't know, we'll see. But try this one, let me know, right? You still need the ISR, but you don't need you don't have to use the state machine. I think that's fine. Got 4 more minutes. I should have more to cover, but we'll still have time on Wednesday. Cover the in-lab stuff, questions on in-lab for Lab 7, all right? Questions or anything?
For the final process, will we be using your template, or is it like we can use our template, or we can make our own?
What, you mean the PCB template?
Yeah.
It has to be, you can propose to me if someone already proposed a different microcontroller. You can propose to me, I have to prove it, right? If you don't want to use PIC, you want to use something else.
Okay, so it's easier to just use your template.
Depends, right? If you know Arduinos, you can have a wireless communication IoT device within like 2 weeks to get big Arduino system. Can do a lot of things. But PIC, if you go wireless, it will take you like a month. I don't know. But for now, I think if you just want to pick up, you just want to use the IR module, for example, with a speaker, like you can use the IR remote to change the channels of music, play different music, use the IR signal, or something else. If you got a microphone, you can integrate that to the PCB as well. But use whatever we have learned makes more sense, right? We learned so much during the semester, and we picked something else to work on the project, which is also okay. I mean, ARM is good because it's good for you to get a job. But I have to approve it, okay? You can feel free to propose any other projects. All right? Okay. We'll see you on Wednesday.